Welcome to the Functional Groups and Basic Chemical Test Simulation. Today you will work with a few common functional groups in organic chemistry, and perform simple experiments that can be used to identify them. This simulation uses voiceovers. If you don't have audio, click the speaker symbol on the top right of your lab pad to switch the play mode. If you disable the sound effects, the lab pad will slide up whenever there are instructions to read. You can select what type of audio you prefer. Deselecting any of the options will mute that option. Click. Using the lab pad is an important way to get the most out of this simulation. Is this the first time you've played a Labster simulation? Perfect. Then let's get started with your first mission. Let's go check out what's wrong with Simon.
Hey, thanks for coming by. This toothache is killing me. I've gotten some pills from a friend of mine, and I really hope they can relieve the pain. She said they contain salicylic acid, and that it's an organic compound with good anti-inflammatory properties. However, I'm a bit unsure if she gave me the right pills. With your chemistry skills, would you be able to check out if they actually contain salicylic acid? Sweet, thanks a lot. See you later then.
Click on Simon's TV to return to the lab. I'm sure you also had a toothache, and remember that it's not a fun experience. Let's check out the chemistry of the pills Simon has been given, and hopefully confirm that he doesn't need to worry about them. Chemical tests are a simple tool to support the identification of a compound or a chemical mixture. In organic chemistry, this is usually used to confirm if a specific so-called functional group is present. Before we get started on Simon's sample, let's first check out a simple chemical test, the Bromine Test. The Bromine Test reveals whether a solution contains unsaturated organic compounds, as the orange bromine reacts with the double or triple bonds, with the orange color disappearing if there is a reaction. Be aware that bromine is actually quite toxic, and can be dangerous to work with. In what way, you may think? Check out the theory if you'd like to know. Let's get you suited up for lab work. Pick up a lab coat from the rack. Put on some lab gloves. Put on some safety goggles. Go to fume hood 1. Alright, here in the fume hood, there are 2 bottles that each contain an unknown compound. You need to figure out which unknown is hexane and which is pent-1E. For support, you also have 2 other bottles, for which we know the contents, pentane and hex-1E. Let's first perform the test on these 2, so we can use them as positive and negative controls to identify the unknown compounds afterward. Add bromine water to 2 tubes. Raise the lab pad for a step-by-step guide. Click on the lab pad for more information. Add pentane to one of the tubes containing bromine. Add hex-1E to the remaining tube containing bromine. Use the microvortex to mix the contents of both tubes. What observation can you make for the solutions after mixing them with the vortex? Well spotted. Bromine reacts with alkenes by disrupting the carbon-carbon double bond and adding bromine atoms to the hydrocarbon. When bromine is consumed in the reaction, the color of the solution is lost, turning the mix transparent. Okay, Now it's time for you to perform the test with the unknown compounds. Perform the bromine test on unknown compound 1 and 2. Interact with the lab pad for step-by-step instructions. Click on the lab pad for more information. Good job. So, which of the unknown compounds do you think is hexane? Brilliant. Since hexane is a saturated hydrocarbon, there's no double or triple bonds for bromine to react with, and the solution remains orange. Very cool. Since you've shown you're capable of performing a chemical test, let's return to Simon's issue. Click the fume hood to go to the wall screen by the lab entrance. Here on the wall screen, you can see the chemical structure of salicylic acid. I've highlighted 3 sections on the structure, with each section being a distinct functional group. There is an essentially infinite amount of organic compounds, and this is possible partly due to the countless possible ways functional groups can combine. Go to Hollow Table 2 to check out the basics about functional groups. What is a functional group then? Functional groups provide reactivity to the organic compounds, and their position in the molecule also determines how the compound is named. Here on the hollow table, you can see formaldehyde, which contains a double-bonded oxygen. That oxygen is a functional group, and when placed this way, the whole compound is called an aldehyde. There are a lot of different functional groups, and some of them contain other atoms than hydrogen and oxygen, such as nitrogen, phosphorus and sulfur. Depending on the arrangement of these atoms, the functional groups are different and provide different properties to the organic compounds. Functional groups are crucial for the reactions in organic chemistry. Go to the functional groups poster. Check out the functional groups on the poster. Raise your lab pad when you are ready to continue. Are you ready to continue? Alright, here come a few questions about functional groups. Remember the structure of salicylic acid? It had a COOH group. Which functional group would this be? Exactly. This is also the primary group that makes salicylic acid an acid. Which other important functional group does salicylic acid contain? You've got this. Phenols have hydroxy groups attached to an aromatic ring, just like salicylic acid. Now, let's get to work on your mission from Simon and see what we can learn about salicylic acid. Click on the back button to go to the center of the row. Return to the screen on the wall next to the entrance. Salicylic acid is also called 2-hydroxybenzoic acid. It's a compound obtained from the bark of the white willow and wintergreen leaves, but it can also be synthesized in the lab. As mentioned earlier, it has 3 distinct functional groups, a hydroxy group in purple, an aromatic group in blue, and a carboxyl group in green. As you know now, the hydroxy group can be part of different functional groups, and when bonded to an aromatic ring as in salicylic acid, the functional group is called a phenol. In fume hood 2 there is a solution of pure salicylic acid in water, prepared using the pills you brought. You will also find water and hexane, which we will use as negative controls. The positive controls for the respective tests will be ethanol, phenol, and acetic acid. You can have a look at the Media tab to see their 2D structure at any time, and check out what it means to have controls in an experiment in the theory pages. Click on the screen to go to Fume Hood 2. As an extra challenge for you, I did not label the 6 test solutions, so you don't know what is in each beaker. Let's see if you can find the salicylic acid solution and confirm that the pills actually contain the functional groups of this organic compound. You will first test for a hydroxy group using the ceric ammonium nitrate test. The addition of ceric ammonium nitrate reagent to an organic compound with an alcohol or phenol group results in the formation of a dark red color. Alcohols in chemistry are very similar to phenols, but here the hydroxy group is not bonded to an aromatic carbon. According to what you know about the salicylic acid structure, what should happen to the solution after performing this test? Alright, we'll find out if your hypothesis is correct after you've done the experiments. Add each solution from the beakers to a different test tube. Raise the lab pad for a step-by-step guide. Click on the lab pad for more information. Add ceric ammonium nitrate to all the tubes. Raise the lab pad for a step-by-step guide. Let me help you with the remaining tubes. Vortex the tubes with the microvortex and observe the results. Click on the lab pad for more. Good work. Which compounds seem to have either an alcohol or phenol functional group? Exactly. Those beakers seem to contain solutions of compounds with an alcohol or phenolic functional group. The ceric ammonium nitrate reacts with them, forming a red or brown color. You can have a look at the Media tab to keep track of the results of the experiment. Alright, now you have narrowed down your options. Let's do a second test to find and confirm our sneaky salicylic acid. Go to Fume Hood 3 on your left. In the second test, you will look for signs of a carboxylic acid group. The addition of sodium bicarbonate to a solution containing an acidic compound results in the formation of some brisk effervescence, as the bicarbonate is converted to water and gaseous carbon dioxide. I've already transferred some of the test solutions for you into 6 fresh tubes, so you can get to work. What should happen to the salicylic acid solution when performing this test? Okay, also we'll see if your hypothesis is correct after all the experiments. Add sodium bicarbonate to a tube. Nice. Now add sodium bicarbonate to the other tubes and observe if anything happens. Alright, which compounds do you think contain a carboxylic acid group based on this test? Well done. You can see brisk effervescence in those tubes, meaning that they contain a carboxylic group. As before, you can see an overview of the results in the Media tab. Put the spatula back in the beaker. Click the fume hood to go back to the wall screen and have a look at the final. Now that you have performed the experiments, tell me, where was the salicylic acid hiding? You can check the Media tab to have a look at the structures of all 6 compounds again. You are a chemistry champion. Compound A was indeed the salicylic acid. It's the only compound that gave positive results in both tests, which matches with the presence of a phenolic and a carboxylic acid functional groups at the same time. So now you can confirm to Simon that he probably doesn't need to worry. These pills seem to be what they are supposed to be. Now, let's check if your predictions were correct. I have more good news. Both of your hypotheses were correct. You predicted what would happen to salicylic acid in both experiments. Are you the next Marie Curie or Robert Burns Woodward? Well done. You've done a great job. Let me ask you one last question. Having a look at the results for the 2 tests you did for compound A to D, can you determine which one is hexane? Brilliant. That's the mindset of a true scientist. You don't have enough data to conclude which compound is hexane. You would need to perform more experiments to determine that. However, you might have noticed that compound F formed 2 layers in the steric ammonium nitrate test. This gives us a clue that this might be hexane, as this compound can't be mixed with the aqueous solution of steric ammonium acetate. We're almost through the simulation now. As a little present, have a look at the 3D structure of salicylic acid on Hollow Table 1. Go to Hollow Table 1. You know, the pills you brought were just aspirin. Aspirin is also called acetylsalicylic acid, and it's broken down into salicylic acid in your body. For the tests in the lab, I did this conversion for you. Simon can trust his friend. She gave him a very common and effective treatment for simple pains and inflammatory processes. Let's go see how he's doing.
I feel so much better now. Thanks for helping me check out the chemistry of the painkillers. Please, join us here at the barbecue.
Let me ask you one last question. Do you feel like you gained relevant knowledge during this simulation? Thank you for your feedback. Your score has been saved together with your 100% progress. Congratulations, you have completed the simulation. We hope you enjoyed it and you feel wiser now.